why am I having this chat with RJ? Most recently, I was at a Velodyne, a LiDAR company. So this topic keeps coming up. I think it'll be interesting to talk about this. So RJ, if you want to add anything else to your introduction, otherwise, I'm just going to throw you under the bus and say, pick one.
I thought I already oops. All right, there we go. I thought I already answered the question this morning, which is you need both, but pick one.
Okay.
I mean, it's a computer vision summit, so I guess I could be controversial and just go with LiDAR, but I mean, cameras do have quite a bit of potential, so yes.
All right. So I think let's dig deeper into it, right? Yes, there are a lot of examples of systems that are only based on computer vision, and then there are systems that are based on LiDARs as well, or only LiDARs. Plus, you've got other sensors too. You've got radars, and then there are still ultrasonic sensors out into play. So I think it really matters on what the application space is, right? And another thing that matters is cost itself. So what I would do is, before I go any further into that, let me ask one of you here, what are your thoughts? Does anyone brave enough to say something? There. Do we have another mic?
Thank you. So traditionally, LiDAR has been computationally expensive, right? And so doing it in real time in the real world usually becomes difficult unless you have like an HD map or something like that to sort of like your fallback plan in case the LiDAR goes awry or whatever it is. You've got an HD map. It's not going to turn left because it's a one-way or whatever it is, right? So I'm thinking that LiDAR has been sort of discounted a little bit just because everyone's getting to latency. Everyone's trying to avoid that accident. So I'm wondering maybe that's why LiDAR has been, cameras have been preferred over LiDAR, but computationally things can change in the future, right? So,
okay, that's a good point.
Yeah, that's interesting. I don't think it's a straight shot that LiDAR is more computationally heavy than cameras. I think it really comes down to your techniques that you're using for each of those sensor modalities. Sure, there's a difference between network bandwidth and computational cost. I think, and given especially given the rich data that comes in with cameras, it's easy to, if you're not careful about how you train your models and deploy them, and more importantly deploy them, you could easily use way more compute on cameras over LiDARs. I think I'll make the comment that I think there are very few systems today, and some of you are probably working on some of these products, but there are few applications, I think, that can do LiDAR only, whereas there are many applications that can be camera only.
Okay, so a couple of things we've picked up, right? So let's build our repository of things to create a story here, right? So you said computationally intensive. You sort of mentioned it depends on the application, but you also said that are there use cases where LiDARs can be used by themselves only? And I think what you're alluding to there is the contextual or RGB information that you can extract, right? So I'm going to come back to that, come back to that in a second to see how we can do it, because I know a person right there has a thought. Go ahead.
Hi, yeah, I have a question, and I'm actually giving a talk about the camera part in the other session just after lunch. So I work on robust models for adversarial images, and I think that's potentially really important for autonomous driving. And there's more details about that we can talk later. But out of curiosity, does LiDAR have something similar? Like, is there an adversarial LiDAR type of input that could fool on autonomous driving? I'm not well informed about that. As far as I know, I don't think there is any, but maybe there is, and I'm not aware of that. And just any comments or general discussion about that? I don't know. Yeah.
Sure. You're the LiDAR expert.
Well, assuming so. Okay, so I think what you were trying to say, if there is a way to trick LiDAR into detecting something else.
Yeah.
So let's talk about both of them at the basics. Let's go back to fundamentals, right? So with your camera, whether you're using CCD or CMOS, you're essentially capturing light and you're converting that into an electrical charge, and you know, depending on what type of shutter you're using, and you're converting that analog information into an output. And then you go through all of those, right? Deburring and all the filters until you create an image. On the flip side, so there are multiple types of LiDAR. So for this discussion, I think let's just assume this is a flying spot LiDAR. So that means you have a set of beams of laser that are emitted and and reflected back from into specific spots and back into the LiDAR, right? So you're doing a direct time of flight. Now there are other ways too. There is a VCSEL-based LiDAR. There is a indirect time of flight. So there are different versions that you can do. So we're just going to assume we're talking about direct time of flight. Now, really what you're calculating is the time it takes your photons to reflect and come back, and what is the intensity of that. That's all you're going to get out of it. Now, can you trick it? I think you can trick, like generally saying, and it sounds very hypothetical, yes, you can, but I mean, you can probably try to, it's not easy, but you can, theoretically speaking. But we're not here only for theoretical stuff, so let's talk practically. I think the closest thing that, in my opinion, is going to come to what you were saying is something like a crosstalk. That's dependent on the wavelength of the LiDAR that you're using, as well as what amount of power you're limited, because remember, if you are on a 905 nanometer versus 1550, you have different conditions on how much power you can shoot out from your laser before it becomes detrimental to human eye, right? So that also limits how well you can create a signature for you to know what really is your own laser that was emitted and coming back, and what is actually noise. So in the end, there are two things that happen, right? One of them is crosstalk, as I said, where there is a signal that's taken from some other sensor. And you can expect, like if you put a lot of robots with LiDARs in a very close space and same type of LiDARs, you need to actually do some sort of clever processing to make sure you're not, reading each other's. It is addressable, right? At the same time, I think when you put the word adversarial in it, you are also sort of signifying that there is an intent to deliberately cause it to do something against it. So I think now this goes into figuring out those corner cases and those use case scenarios and then solving it. So to sum this up, yes, there are crosstalk issues. You're going to get noise issues, but that's for any sensing modality, right? Whether that's radar, ultrasonic, cameras. I mean, cameras could probably be like you're probably going to talk about, although don't go to that talk because I want you all here. It can also be fooled, right? So I would not choose one or the other based on that aspect. Now, what does that tell us, when we come back and we look at our metrics? And that is, in order to address that, in order to sort of make it practical, what's the cost? What's the complexity, both mechanical and in terms of algorithmic? And what's sort of the reliability part of it, right? And all three of them actually apply pretty well to both LiDAR and cameras, right?
Yeah, no,
Don't agree with me. I want you to
That was a very complete answer, by the way. Thank you.
Zabit did a great job on discussing on the hardware side. I'll just make a quick comment on the software side of things. The reason we talk a lot about robust adversarial issues with camera is because, in many ways, it's because the camera, the machine learning revolution for cameras, right? And that's when, we've had the discussion about machine learning having, and the functional safety around that. But in contrast, if say computer vision had gone back to circa 1980s and 1990s, where it's more geometric feature based, there's probably going to be less talk about adversarial models. I mentioned that because in the LiDAR world, while there are obviously a lot of machine learning advances, ML techniques for LiDAR, if you fall back onto geometric approaches, and that is the strength of LiDAR, dense 3D view and all that, then the likelihood of adversarial approaches, not that it's impossible, you could, but the likelihood of that drops because you are fundamentally grounding it in geometric techniques, right? So as we do more and more ML in LiDARs, there is a very good chance, you do more on ML and you remove the geometric fallbacks, that's when adversarial things will come up.
Thank you.
One quick question is like, what is the typical turnaround time to process a LiDAR data for the usage?
Well, go ahead.
Sorry, do you mean inference time or training time or?
Yeah, everything like in common, like if you get the data from like a LiDAR, like what is the required time or time is required to use it for the utility purposes? Like a week or so, or like something.
So if you're including data collection and
Yeah,
training and all that, I mean, that really falls back to your ML ops pipelines and how automated that process is, how much human in the loop for data labeling and all that. Suddenly, as a general norm, data labeling for LiDAR is more intensive than 2D labeling for semantic segmentation and stuff, just given the complexity, of looking at all that point clouds. But that's also where there are a lot of advances with bringing in ML to help auto-label stuff or self-supervised learning in those spaces. And once you can do that, and assuming you have all the compute resources, then the delta is not as great.
Yeah, and latency, so I think that goes back to latency, right? And also goes into the safety case itself. At the same time, I think you're probably also asking, hey, what does it take to process let's say a photon of light coming back, right? LiDARs are a little bit complex at the moment, right? And let's also keep in mind where cameras and LiDARs are. The world produces about 1 billion cameras a year, right? LiDARs, you're talking about maybe a few thousand a year, right? So it is a very, very early stage technology, although in the last few years you have started to see a lot of interest and a lot of growth. At some point, I mean, an opinion could be made that LiDAR was gating the deployment of L4 vehicles. We can talk more about this. This is not my opinion at the moment, but it depends on, again, to the application. So a lot of the LiDARs, and I'm not saying all the ones do it, but a lot of them has a specific processor or an FPGA that processes the incoming data before it's transmitted out into your ML pipeline. Now, the actual latency of that is dependent on your scanning mechanisms. It's dependent on what type of LiDAR you have. But you can easily get something like 25 hertz and above, and that should be more than sufficient for a lot of the safety cases that we have to make, right? So if we go in towards a safety case and you say, hey, I'm driving in an urban area, 25 miles per hour, and I need to stop within 300 feet or so, you'll be looking at 100 to 300 millisecond latency from the time that you have some stimulus to the time you need to stop. And I think 300 milliseconds is something where you will deviate up between LiDAR and camera and your sensor fusion and localization and everything to actually meet that. So what I'm trying to say here is that I don't think the latency is the gating factor at the moment, but certainly there are specific use cases and applications where cameras can actually be, certainly be faster. So yeah, I think that maybe answers your question. Go ahead.
So coming from my background as autonomy engineer, so I'm mostly interested in the mapping, and for the autonomy system to work, we need a map, and I think that's where the camera and LiDAR, one of the major differences come in. And for instance, Tesla is primarily relying on camera to maintain their map and in real time process their map and do all that. And Waymo is relying on LiDAR-based HD map. I'm from Hyundai and Boston Dynamics, and it's really hard to maintain a global scale LiDAR HD map and to just up to date, have updated to reflect all the situation, construction site and everything, all that. And and because RJ is working toward making a robotaxi in Zoox to make it available for every city, right, in the future. So in that application domain, I'm just interested to know your opinion on what it would look like like camera versus LiDAR. But like my personal opinion on Tesla, I think in terms of reliability, we should use LiDAR and camera, like because they compensate each other's pros and cons. So like for sure we gotta use sensor fusion and all that, but yeah, just in terms of the map and how to maintain the autonomy system and make it scalable, that's our keyword like for this conference. Yeah, I just want to hear the thought there.
Yeah, I think that's a great question. I think I'll make a few comments. First, in many ways, your question is not so much, in my opinion, not so much a LiDAR versus camera thing, but really about, say, HD maps, regardless of the modality, versus sort of a more pure online approach. Of course, there's also the combination of both offline mapping and then online to sense, world changes and stuff. To your point about LiDAR versus cameras and the compute or the memory required, in most cases, in most scenarios, you actually, either sensor modality will work from a sort of memory usage perspective. In a robotaxi sense, at least for those of us who are working in robotaxis for a single market, we're focusing on city by city, right? In that a robotaxi is not expected to go from SF to New York in one ride. It's not going to have the power and the charging infrastructure. So, as far as the memory required to load an entire city's map, for instance, that's probably okay in either modality. Visual mapping and localization is not necessarily that much memory bandwidth. It's not necessarily as low as one might think. There are ways to optimize both, but optimize the memory required, but that applies to both camera and LiDARs. So I think where you make a great point about scalability and all that, but I think that part is a bit more sensor agnostic.
Yeah, I think that's a pretty good point, right? What you're also sort of painting, or you're asking to paint a picture, is the whole sort of landscape. Yeah, camera versus LiDAR sounds very binary, right? Or do we have to pick one or the other? And to be honest, if it is possible, regardless of which sensor it is, my opinion would be that we should absolutely just pick up one sensor and go with it for a lot of reasons, for scalability, for cost, for reliability, for sort of production and everything. But right now, there isn't a one sensor, in my opinion, that can work at least from the robotaxi perspective, right? So that's why you see the sensor fusion. You mentioned HD maps. You also mentioned HD maps. Mapping sort of helps. Like if you have that data, why don't you use it? Why do you need to recreate everything all the time? Now, I think in order to sort of answer that question that you were saying, right? But let's think about the safety case, and then we can also think about robotaxi versus L4 cars. It's actually very different if we think about it, right, from the business perspective. Safety case, if you just look at some numbers, right? In 2020, you had about 38,000 road fatalities, right? 2021, that was about 42,000. Between 2010 and 2020, there has been almost over a 50% increase in that, right? So this is a huge problem. And I'm only talking about United States. I'm not talking about the rest of the world. Let's dig deeper a little bit into that. 38,000 that I mentioned 2020, approximately 6,500 were pedestrians. So these are people who are not even in the car. Like they have nothing to do. They're maybe just going from grocery shopping after, just walk out or some experience from Amazon's store. And unfortunately, they end up in a bad situation, right? See, that's almost, 18%? And if you break it down even further, about 75% of that is in dark conditions, right? So now you say something like 12 to 13% of pedestrians or fatalities in the road are happening at conditions that are less than stellar, right? So that sort of paints a picture of two issues that I see across the sensor domain. And one is ambient conditions, right? And then the other is, which was also alluded to, is stochasticity of the problem. So a robotaxi or any autonomous system that needs to operate out and interact with public and not behind cages need to have ability to work in varied ambient conditions. That's one key point, right? Second is you need to have some safety guarantees. Now, LiDAR can be, not all LiDARs, but a LiDAR can be a deterministic sensor because some of these could be designed inherently, and if you're actually processing the data in a certain way, it can give you guarantees on within your accuracy and precision bounds that you will see an obstacle, right? On the other hand, camera is kind of hard to be stochastic because I think someone mentioned earlier today, you build your ML pipeline, you have your computer vision in it, and you detect a corner case. You cannot trace it back and see why did your neural net actually missed it. What you're going to do, you're going to add that data, and you're going to retrain your neural net, and you're going to test it again, right? So you're going to try to get some statistical completeness to that. But there is no guarantee that that situation is not going to pop up again, right? Now, with that said, again, I'm not sitting here and saying, oh, LiDAR is the answer here. There are situations where camera is going to be definitely needed. I mean, you can now add reflectivity to LiDARs, which can give you some more segmentation and things like that. But there's also the other main elephant in the room, which is cost, right? Not too long ago, LiDARs would cost tens of thousands of dollars, right? Now they cost thousands of dollars, right? They're really, they're quite a bit more expensive than a camera. A camera you can get for $20, right? You can get a radar for like $35. So it puts us in this situation where are you building a service like a robotaxi where you're going to take the cost and spread it over, or you're building an L4 car? Because if you go and you say, hey, I'm going to buy a $50,000 car, and okay, you want it to be L4, put another $100,000 on it, suddenly, I don't know if you have another $100,000 just lying around to say, okay, I'm going to put this in my car, right? So that's sort of like the things that puts us in this situation where it's difficult. But yeah, I mean, any thoughts on that?
Yeah, no, I mean, I think great points there. We spent a lot of time talking about robotaxi during this session, partly because of my background. But I mean, it's worth noting that there are a lot of folks here working in a wide range of applications, even robotics applications. Each application is really different, and in some cases, you can get away, you need to get away with just a camera. Some you can't. Say in the former with drones and stuff, you're never going to put a meaningful LiDAR on that. But on the other end of the spectrum, in the warehouse space, for instance, with some of the European regulations, you can't do that with cameras, at least not yet. And you do need to rely on LiDAR. So it's really about understanding each of these sensor modalities and your specific application.
There was a question there.
Yeah. Hey, to build upon your answer before, the solution for the bikers' fatalities cannot be that someone has to expect a $50,000 car with a LiDAR sensor to be next to them when the event happens. So the solution could only be if the intersection where the pedestrian or the biker is somehow has this information that there is a biker with certain fidelity that can be passed to cars with or without sensors, right? So do you anticipate a future where LiDAR is not usually, like it is being talked now, is not always applied from in-car navigation perspective, but more of a distributed or a hybrid solution where the infrastructures, vehicle-to-vehicle communication increases the coverage of LiDAR or the application of the LiDAR beyond a situation where you expect a car has to make this decision and you don't have all those cars doing that level of autonomy, right? So how do you see the future? Where do you think the most value will lie?
Yeah, I don't think I have to imagine that. I think there are companies that are already doing that. In fact, there is a company called Cavnu that they are trying to build specific lanes that would enable V2X and enable cars to essentially be to some level of autonomy between L3, L4. I mean, I'm not trying to, I'm not claiming to know what they're doing. I'm just saying what I read. So there are companies that are already doing that. I mean, so in Bay Area, you have these fast track lanes. I think in Boston, you've got the Easy Pass lanes. Are there? I don't know. I mean, it's not a very different concept from that, right? It is possible. Again, I think we have to get creative when we're looking at cost and we're looking at how we can actually move the autonomous cars up forward. And there's a possibility that you do not need, you can put LiDARs on the infrastructure or cameras on the infrastructure. So when you enter that lane, now you have sufficient, of course, it creates additional problems, communication problems, making sure latencies, and how do you again close the safety case, but there is a possibility, right? You are controlling your environment, and you are also, maybe spreading the cost on a bigger thing. So look that up, definitely. Also to clarify, I meant pedestrians, not bikers, before it was pedestrians. But
Yeah, I guess I'll just make a quick comment that, if we could redesign cities from the ground up and restrict who enters and leaves a specific geofence, we would absolutely do that, right? And in fact, some Asian cities are very much trying to push for that kind of concept. But the world doesn't work that way, and the world doesn't yet believe as well that self-driving vehicles necessarily are the right solution, for good reasons. So in that context, in fact, the transition is often the most challenging part. And the V2I, V2V kind of thing is one where it will absolutely help, but then you'll never be able to always rely on that in terms of for scale. And that's usually the reason why that conversation stops in its tracks, because it doesn't scale as quickly.
yeah, so one more question.
Hi, thank you. My name is Anand, and just quick point, I'm looking for exciting opportunities if anyone want to talk to me later. My question is, you mentioned some limitations before about color cameras and your use in robotaxi. In taxi, you're using radar, LiDAR, and thermal cameras and color cameras. Are there other cameras or types that you are interested in using? And if you see so many limitations of color cameras, would you think of just discarding it from your design?
So first up, we're absolutely hiring here in Boston as well. So let me maybe to directly answer your question. No, I don't think we will ever get rid of color cameras. In fact, I talked about color cameras in that there are a lot of advantages with it, and that's what we all use to navigate around the world. So it'd be crazy to not use cameras at all. That said, there are limitations, and all that conversation that we just had about robustness and safety case, and having multiple sensor modalities and understanding the strengths and weaknesses and the redundancy overlaps is critical. That's really where we come from. It's Tesla, for instance, and other companies have demonstrated what you can do with color cameras. So I don't want to downplay that at all. In terms of new sensors and all that, there's always a lot coming out. There's ground penetrating radar coming out from here in Boston as well, and other sensors. There's always going to be new advances in both sensing and chip technology that we've heard about and stuff. I think I would just add that the challenge from trying to build a product like a robotaxi, which needs to tightly integrate hardware, software, and the safety case, means that the pace at which you can just entertain new sensing technologies is going to slow down. And as we lock into a specific revisions of the product, and then we can, as we roll it out, understand and then upgrade, just like you upgrade your iPhones. Probably not on a yearly cadence, but there will be some kind of progressive updates where we incorporate new sensors as they mature and also become cost effective.
Yeah, and you can also think about sensors that are software defined, and you can start to update them without having to always replace the hardware. But I think that's spot on what you were saying, RJ, in the sense that robotaxis are essentially a use case where you can close on cost, likely. So you can use them as your, paving the way towards more individual, if individual car ownership model even remains, and that remains to be seen, right? We've gone back and forth where, where there is a lot of sort of enthusiasm of a non-ownership model, and then people come back and say, no, not now. I think, we're just at time, so I'm just going to say a couple of things, and we can close. I think it's a question of what all needs to be done together. So that's different sensing modalities, that's improvement on hardware and software and efficiencies and accelerators, infrastructure changes that allows us to build these specifically defined ODDs to enable certain type of service, which is at the end of the day beneficial and makes economic sense for us. I don't think we're going to get a magical L4 vehicle drop anywhere or L5 vehicle drop anywhere in the world and operate. I think it's going to get slowly built up. And as you mentioned earlier, there are other things that also need to move. Regulations need to move together. There are sort of governmental side stuff where you need, if you're going to build infrastructure on roadways, how do you get approvals for all of that? And when do you actually get permission to do and operate? So we are over time. Do you want to say a few more, just any closing remarks, or we can let people go for lunch?
Sure. Very quick comment on a slightly different spectrum, almost a bit of a self-critique to wrap up, in that when we start doing a lot of this sensor fusion with a lot of different sensor modalities, there is also a big risk, which is that we start treating all of these as crutches and over-relying on LiDARs, for instance, as an example. But it could go in either direction. And it's important for us to ensure that we don't overly rely on it. And we actually take the best parts of sensor fusion, which is redundancy and robustness, as opposed to just crutches and say, oh, we have LiDAR, therefore the problem's going to be easy. You really can do a lot with your sensor modalities, and we need to leverage that and not get lazy if we're actually going to truly solve this problem.
Yeah, absolutely right, because that restricts scaling. And I think, there is one possible future that I think can happen is where you have some type of cameras that are doing everything, and you may not even need LiDARs. Or I think there are these flash-type LiDARs that will probably get more cost reduced because they're going to get made by, Sony's already producing a VCSEL SPAD array that a lot of people can now buy and actually put them into a product. So you essentially end up these LiDARs, which are essentially cameras, just a different wavelength, right? Which are actually going to get cheaper and cheaper. They do not solve all your problem. For instance, they do not work very well against retro targets or certain corner cases, but you get closer and closer to it. So it's all open. I don't think this is sort of settled yet, but I'm just looking for the next 3 years when we have, as I said earlier, when we have fully autonomous vehicles. All right? Well, thank you, RJ. Appreciate your time.
Thanks so much, everybody.